Today we want to talk about applications of systems of equations. In other words, where would we see systems of equations in the real world? Two common applications of systems of equations that relate to the real world are money problems and break-even problems. As we solve each of these word problems, we want to keep the following 4 steps in mind. The very first thing we want to do is define our variables. Okay, so pick any 2 variables that you want to use in your problem, but you need to make sure that you tell somebody what the variables are representing. The next thing you're going to want to do is create a system of equations. Remember, a system is 2 equations with 2 unknowns. The next thing we want to do is solve our system of equations. We've got 3 methods that we can use for solving: graphing, substitution, or elimination. Finally, we want to make sure that we write our solution as a complete sentence, answering the question that was posed in the problem. In our first example, it says that Carmen is selling tickets to a play. Each of the adult tickets costs $4, and each of the student tickets costs $2. The total number of tickets that Carmen sold was 260, and the total amount of income that Carmen took in was $700. The question is, how many of each kind of ticket was sold? We know that there were 2 kinds of tickets sold. The question was, how many of them? This question is going to help us to write our let statement or to define our variables. We have 2 types of tickets that were sold. They were adult tickets and student tickets. So I'm going to let A represent what I don't know, which is the number of adult tickets sold. I'm going to let S represent the number of student tickets sold. Okay. So in our defining our variables, we're picking 2 variables and we're telling somebody what they're going to represent. Okay, use the question to help you. The next thing we want to do is to write a system of equations. Remember, a system needs to be, in this case, 2 equations to help us solve for the 2 variables we don't know. One of the things that is listed in the problem is how much an adult ticket cost and how much a student ticket cost. Those are both dollar amounts or money. We also know that Carmen took in $700. So if we put these ideas together, the total cost or the total amount of money we made on adult tickets was $4 times the number of tickets that people bought. The total amount of money that we made on student tickets was $2 times the number of tickets that were sold. And we know that together they made a total of $700. The other thing that's mentioned in the problem is that there were a total of 260 of the tickets sold. Well, we sold 2 types of tickets. We sold adult tickets and we sold student tickets. So the 260 comes from adding those 2 types of tickets together. So the number of adult tickets plus the number of student tickets needs to equal 260 tickets that were sold. Next, we want to think about what method we would want to use to solve this. Based on the fact that our A's are lined up, our S's are lined up, and our constants are lined up, elimination might be a good option. We also have an equation down here where A or S could easily be gotten by themselves or solved for. In that case, you may choose to use substitution. For review on this one, I'm going to use elimination. Okay. In order to eliminate the variables, remember the coefficients need to match. So in this case, I am going to get rid of my A's by multiplying the second equation by 4. I'm going to leave the first equation, 4a plus 2s equals 700, and I'm going to come here and multiply that second equation, by 4. All right, so 4 times a is going to give me 4a, 4 times s is going to give me 4s, and 4 times 260 is going to give me 1040. In order for these to eliminate, I'm going to need to subtract the 2 equations. 4x minus 4x cancels out. 2s minus 4s gives me negative 2s. And then 700 minus 1040 gives me negative 340. Divide both sides by negative 2, and we figure out that the number of student tickets sold were 170. right? In order to find the number of adult tickets sold, we'll probably look easiest to use this bottom equation. A plus S equals 260, and I know that S is 170. So A plus 170 equals 260. I can subtract the 170 on both sides, and I find that the number of adult tickets sold were 90. Our last step is to write our solution as a complete sentence, making sure that we answer this question. How many of each kind of ticket was sold? Well, I have learned that there were 90 adult tickets and 170 student tickets sold. Right. In our next example, it says that Anna has 4 times as many nickels as dimes in her bank. Her bank account contains $7.20. The question is, how many nickels and dimes are in Anna's bank account? So again, going back to the question, how many nickels and dimes are in Anna's bank account will help us learn what we need to be solving for. We want to know the number of dimes and the number of nickels. So our let statement, you may choose any variables. I'm going to use D for dimes and N to represent nickels. So D is the number of dimes that Anna has, and N is the number of nickels that Anna has. Okay, now we're ready to write our system. The first thing it says is that Anna has 4 times as many nickels as dimes. So the number of 4 times as many nickels as dimes. So if I think about that statement, does she have more nickels or does she have more dimes? And so she ends up having more nickels. So the number of nickels is equal to 4 times the number of dimes. She has 4 times as many of these as she does of those. The next thing we need to do is to think about the fact that it says that there are $7.20 in her bank account, right? Now, the previous problem told us how much an adult ticket and how much a student ticket costs. This problem doesn't indicate how much a nickel or how much a dime is, but we know that. We know that a nickel is worth 5 cents. So 0.05 times the number of nickels that she has will tell us the total amount of nickels, total dollar amount she has. In addition to that, she has some dimes. We know that dimes are worth 10 cents. So 0.10D will tell us the total value of her dimes. And together, we know that this total value that she has is $7.20. The next thing we want to do is decide how to solve. Seeing as how this equation already has N isolated, the easiest way to solve this system would be with substitution. Substituting the top equation into the bottom equation, we end up with 0.05 times 4D plus 0.10D is equal to 720. When I multiply 0.05 times 4, we end up with 0.2D plus 0.10D is equal to 720. Back in Unit 2, we talked about eliminating decimals. You are welcome to eliminate your decimals here if you would prefer to not work with them. If you're fine with decimals, you may continue on. If you add your like terms, 0.2D plus 0.10D gives us 0.3D. And when we divide both sides by 0.3, we find that D, or the number of dimes, is 24. Subbing that back in, easiest equation to sub in for would be the top one. The number of nickels is equal to 4 times the number of dimes. So 4 times 24 makes the number of nickels to be 96. Okay. She has 4 times as many of these as she has of these. Okay. All right, we're ready to write our sentence now. The question asked us how many nickels and dimes are in Anna's bank account. So we just need to answer that. Anna has 24 dimes and 96 nickels in her account. Okay. So make sure that your sentence includes context from the problem. All right, a second type of word problem is a break-even problem. It says you're starting a lawn mowing business. To get your business going, you need to buy a lawnmower for $295. You estimate that you will be using about $1 worth of gas per lawn. Most of the lawns around your neighborhood are about the same size, so you decide to charge a flat fee of $40 per lawn. To help you get started, your very generous uncle also invests $100 into your business. How many lawns will you need to mow to break even? Right? So thinking about the question, how many lawns will we need to mow in order to break even? All right, in a break-even problem, what happens is the amount of income we bring into our business is going to equal the amount of expenses we put out. Okay, so income will equal expenses. So let's go back through and read our problem and label each piece as income or expense. To get your business going, you need to buy a lawnmower for $295. That's money going out, so that $295 is considered an expense. You'll estimate that you are using about $1 worth of gas per lawn. Again, that is an expense to your business. Most of the lawns in your neighborhood are about the same size, so you decide to charge a flat fee of $40 per lawn. That is going to be income coming into your business. And finally, to help you get started, your uncle gave you $100, also income coming into your business. All right, one of the things that we were asked to find is how many lawns you're going to need to mow to break even. All right, so in terms of a let statement, I'm going to let X equal the number of lawns that need to be mowed. Remember, a system also has a Y value. So in thinking about this, what would our Y value represent? Right? So not only are we mowing lawns, but what we're doing is having an exchange of money. So Y is the total amount of money. Okay? And that money can be an income money or it can be an expense money. All right, looking at our system of equations, let's talk about the income that we have there and write an income equation. So my total amount of income is going to equal, I get $40 for every lawn that I mow, so 40x. And then my uncle gave me $100 to start up. So I get to add $100 to that as income. All right, looking at our expenses, we are going to have to buy our lawnmower for $295. Okay, that's a flat $295. So the total amount of money for the expenses or the cost is going to be $295 plus I'm going to have to buy $1 worth of gas per lawn. So in this case, 1x. Remember we said earlier that a break-even problem, our income equals our expenses? Notice that both of these equations say y equals. In this case, we already have a variable solved for. Therefore, the easiest method to use here is substitution. We can substitute the top equation into the bottom equation, okay? In other words, we can set the two equal to each other, right? The income and the expenses are going to be equal. So y is equal to 40x plus 100, and y is equal to 295 plus 1x. So 40x plus 100 is equal to 295 plus 1x. Combining our x's, we get 39x plus 100 is equal to 295. Combining our constants, we get 39x is equal to 195. And when we divide, we end up finding the x, or the number of lawns we need to mow, is 5. At 5 lawns, our income and our expenses will be equal. We actually don't need to go any further and find why, because the question asked us how many lawns will we need to mow to break even. Remember, lawns was our X value, and we found our X value. So we need to mow 5 lawns to break even. Okay. All right, final example. A cell phone company offers 2 payment plans. Under the first, there is a monthly fee of $40 and a charge of 30 cents per minute. The second charges a $25 monthly fee and a 50-cent per minute charge. We want to find the number of minutes used per month that will produce an equal cost for the 2 plans. So instead of saying breaking even here, we want the cost of the 2 plans to be the same. Then we want to know, what will the cost for each plan be? Okay, so we have 2 questions here. Find the number of minutes used, and also what will the cost for each plan be? Okay. So thinking about those 2 things, that will help us to write our let statement. The first thing we were asked to find is the number of minutes. So we're going to let X represent the number of minutes. And in this case, we'll let Y represent the cost of the plan. All right, for our 2 equations, the first plan, the cost can be found. There is a monthly fee of $40 and a charge of 30 cents per minute. So we have a flat monthly fee of $40 and a charge of 30 cents for each minute that we talk. In the second plan, there is a $25 monthly fee and a 50-cent per minute charge. So our second equation is going to say 25 plus 0.50x. Again, because both of these equations already say y equals, substitution is going to be the easiest method to solve. Right? Again, I know that y is equal to 40 plus 0.30x. I know y is equal to 25 plus 0.50x. I wanted to know when we will have equal cost, so I can set these equal to each other. 40 plus 0.30x is equal to 25 plus 0.50x. Okay. Combining our like variables, subtract the 0.50x on both sides. We get 40 minus 0.20x is equal to 25. Combining our constants, we'll subtract 40 on both sides. So negative 0.20x is equal to negative 15. And then dividing both sides by negative 0.20, we end up with x being 75. Okay. Which questions does that answer? If you said to find the number of minutes used per month that produces equal cost, you are correct. So at 75 minutes, the 2 plans have an equal cost. The other thing we were asked to find was, what will the cost for each plan be? In order to do that, we need to figure out the value of y. Plugging back into either of our original equations, I'll just take the top one. Y is equal to 40 plus 0.30 times 75. Right? Multiply 0.30 times 75 and add the 40 back, and we end up with y equals 62.5. So interpreting that, it means that the cost for each plan will be $62.52.